Good morning, everyone. I'm Chiara Cinelli, a second-year PhD student in computer science at the University of Genoa in Italy. And today I will present you CovRev, a Python toolkit for preprocessing pipeline rewriting, ensuring coverage constraint satisfaction. Let's start by introducing the problem. Analytical pipelines processing real data are often very complex, and data preprocessing tasks can introduce bias at different levels. Take, for example, data transformations. They are often defined in terms of selection, projection, join operation over tabular data and can reduce the number of records related to some protected groups. As a consequence, these protected categories can be underrepresented in their transformation results, and this might introduce bias in the following analytical steps. Such problem can be tackled by setting specific coverage constraints aimed at increasing diversity with the goal of limiting the introduction of bias. While most existing approaches chase coverage through data repair, in our previous work we proposed an approach for minimally rewriting SPJ operation so to guarantee that the transformation result contains enough entries related to the protected groups of interest. CovRev, the system we are going to demonstrate, relies on this approach for ensuring coverage constraint satisfaction in the context of Python pandas pipeline. The proposed approach, when applied over tabular data, relies on three main concepts. Some sensitive attributes that are discrete valued attributes used for the identification of protected groups. Typical examples are gender or race. A preprocessing pipeline with a special reference to data transformation operation. In CovRev, we focus on monotonic SP query corresponding to slicing operation in Python pandas pipeline, and coverage constraints corresponding to conditions specifying how many entries of protected groups instances should be returned by a data transformation. We aim at ensuring coverage constraint satisfaction through rewriting, since in this way we trace how the data transformation is modified, thus guaranteeing transparency. The rewriting relaxes the original transformation by identifying the smallest query containing the original one at the lowest distance from it. In order to detect the coverage-based rewriting, each query is first rewritten in a canonical form and then represented as a point of a multidimensional grid, representing an approximate search space. The grid has one axis for each selection attribute of the original query, and each axis is then discretized using typical bucketing approaches like equidepth. In order to detect the optimal coverage-based rewriting, we visit the grid starting from the point corresponding to the input query, one cell after the other at increasing distance, and pruning the space, exploiting the properties of such grid for improving efficiency and scalability. For each point, cardinality estimates are required to check minimality and coverage constraint satisfaction. To this aim, for the sake of extensibility, we rely on sample-based estimates. CovRev allows the user to select two different rewriting modalities, fast but potentially inaccurate sample-based processing, or accurate but potentially slower processing over the real dataset. Notice that approximation and sampling impact the accuracy of the detected solution and need therefore to be carefully tuned. Now we are ready to present the CovRev logical flow. First of all, the user should specify the input dataset with the related sensitive attributes, the pandas pipeline, and the coverage constraints. As the first step, CovRev analyzes the pipeline, identifies slicing operation that may be rewritten, and produces an annotated script highlighting these operations. The user can select the operation she wants to rewrite, specify the execution type, and modify the input coverage constraint if needed. In the second step, the rewriting algorithm is executed according to the approach discussed so far. For each rewritten operation, many impact indicators related to result accuracy are generated. Based on such indicator, the user might want to reconsider some of her choices, thus producing a new annotated script. Otherwise, if she's fine with the result, the final script is returned as output. In the demonstration of CovRev, we pursued three goals. To ascertain the feasibility of rewriting slicing operations to ensure adequate protected groups representation by means of coverage constraints, to explore the effect of such rewriting with respect to protected groups membership on result accuracy, and to compare in terms of efficiency and accuracy the executions of alternatively written pipelines sharing the same goals in terms of coverage but using different rewriting approaches. More precisely, two datasets will be available, typically used in assessing fairness or diversity constraints, while sensitive attributes and coverage constraints will be selected and defined by the user. For each dataset, some pandas script will be available as a starting point to show different combination of projection and filtering operation, leading to a different ratio among different groups for sensitive attributes. The live demonstration will be conducted in such a way to show you different coverage scenarios, depending on whether the constraints are satisfied or not satisfied, and or whether the user is fine or not with the results. If the number of active users will be high, Clicker's instant polling tools will be used to select the input to provide to the system in the various steps. Now, to give you a feeling of what Cover can do, I will present you one of the possible scenarios. This is Cover, our tool, so let's start. In this first page, the user can select the dataset and it can choose between these two available datasets. Now, for example, we can choose adult dataset. On the right, you can see a brief description of the selected dataset and the list of the available attributes. Now, let's choose the attributes that we consider sensitive. So let's choose sex. We can see below the selected sensitive attributes with a list of the available number of values for each of them in the dataset. By clicking on this button, we can set the coverage constraints. For example, now we can suppose to would like to obtain in our result at least 100 females. So we set the coverage constraint, selecting females and writing 100. We click on the next button and we move to the second window. Here we can select the Python script, and as mentioned before, there are 3 available scripts. And for example, now we can select the first one, in which there are 2 filtering operations and the training of an SVC model. Clicking on the next button, we move to the script annotation window, where we can see on the right the code with the highlighted slicing operations that are selectable on the menu on the left. For each selectable line, we can choose the execution type and we can select fast or accurate according to the usage of the sample or the dataset. And if we want, we can modify the coverage constraints. Notice that the selected line is highlighted in the code with a different color. We can select more than one line, but now suppose that we want to rewrite only this second slicing operation, and suppose that the coverage constraint is okay. So we click on the next button and we call our rewriting algorithm. For each rewritten line, we can see a tab showing some statistical information to analyze and evaluate the rewriting slicing operations. In the first section, we can see the new conditions in form of both text and visualization. The second section contains information on the approximation error and the proximity that are measures that we have defined to evaluate the effectiveness of the proposed solution. In the last section, we can see some insight on the cardinalities before and after the rewriting. Here we can see a tick for each satisfied coverage constraint. At this point, the user could be satisfied or not satisfied by the obtained result. If she is not satisfied, she can come back, make some little changes in order to obtain a better result. On the other hand, if the results are okay for the user, and in this case, we suppose we are satisfied by obtained results, we can confirm, and Cobrev will show us the new rewritten script, highlighting the lines that have been modified. I hope my presentation gave you an idea of what Cobrev can do. And for further detail, meet us at the Demos in Action section.